Hey, and welcome to Pomodoro Joe for Tuesday, September 12th, 2023. Today we're looking at LeetCode problem 1647. Minimum deletions to make character frequencies unique. This is a medium problem. All right, we're given a string S. It's called good if there are no two different characters in S that have the same frequency. Given a string S, return the minimum number of characters you need to delete to make S good. The frequency of a character is blah, 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 number of times it appears, so on and so forth. Got it. Okay, so we're given a string. We need to count the number of times all the characters appear in the string. So that gives us the frequency. So if, let's see, here's an example. We have AAB. The frequency of A is 2. We have 2 A's and 1 B, so the frequency of B is 1. Now we have to make sure that no two characters have the same frequency. So A has 2, B has 1. They're not the same frequency, so we're all good. We don't have to do anything. Now this one, 3 A's, 3 B's, and 2 C's. So A has a frequency of 3, and B has a frequency of 3. So this is not good. We need to remove either 1A or 1B, and then we'll have another problem. So then we'll have either A has 2 and C has 2, or A has 3 and B has 2 and C has 2. So we have to remove two characters here. We have to remove 2 A's or 2 B's, or an A and a C. Anyway, so we have to remove 2. And so on and so forth. All right, so we'll put 25 minutes on the Pomodoro timer and we will get started. So let's start off with some result. We'll set it to 0 to start and we will return our result at the end. All right, now the first thing we'll want is to calculate our frequencies. So this will be the frequencies of all of our characters. Now we could use a counter for this. Now Python gives you this thing called a counter. We could do that. I'm just going to go through and count them myself. So we'll have a dictionary where the key is the character and the value will be the count of that character. So let's have some, we'll call it freaks. All right, so this will be a default dictionary. And let's see, we need to keep track of the characters and their count, so this is an integer. All right, now for every character in our string, we'll just count. So frequency at this character, frequencies at this character, C, plus equals 1. So now we have a dictionary where the key is a character and the value is the frequency. Now that we have this, we need to go through and figure out, well, which frequencies are unique and which ones do we have duplicates of? So let's let's create another dictionary that will map the frequency to the number of characters with that frequency. So in our case over here, we've got our frequencies, so we'll have A mapped to 3, B mapped to 3, and C mapped to 2. Now we want to flip that around and have 3, the frequency 3, mapped to 2, because we have 2 different characters of frequency 3. So let's have this here. We'll have a frequency map. Is that what I want to call it? Maybe a frequency to count map. And again, this will be a default dictionary of its. All right, and now we just go through every frequency in our frequencies dictionary. So for this one, I'll actually go through and use the items function of the dictionary. So if I went through for every key in my frequencies here, this will give me all the characters, the keys, and then we'll have to use that key to index into our dictionary to get the count. Or we can do key comma value to get our key value pair out of frequencies, but we have to call the item function. So this will give us the key value pairs for every key and value in our frequency dictionary. All right, now I'm just keeping track of the frequency to count map now. So in this case, my frequency to count map for this frequency, that's my value. We'll just add 1 to it. Now let's see. At some point, I will be going through and processing all of the frequencies that occur more than once. So maybe I'll keep track of which frequencies are actually duplicated here. So let's have another thing. All right, I think I'll approach this the way I approach graph traversals. I'll keep track of what are the things I still need to process, and I'll put those things in a queue. So I'll have some Q, that'll just be a list. And here, if our frequency count is greater than 2, that means we have more, or no, greater than 1. That means we have more than one character with the same frequency. I'm going to throw that frequency into this queue, and we'll have to process that. We'll have to basically change the frequency by deleting a character. Now, we don't actually need to keep track of the characters themselves. We're just keeping track of unique frequencies. So in this case, if my frequency, I'll grab this whole thing. So if this frequency has more than one character with that same frequency, then I'm going to add this frequency to my queue, because I know I need to process it to basically remove one character to lower the frequency. So the queue for this, we'll just add the value. Let's see, I need to append the value. All right, so now I've gone through, I basically collected all of my frequencies into this frequency to count map, and then I've taken all those frequencies that occur more than once, I put them into this queue. Now I'll have to go through my queue and essentially reduce some of these frequencies so that we no longer have duplicates or two characters with the same frequency. So let's see, for this, I'll just do while I have some queue. So I still have frequencies I need to process. I'll grab the frequency out of that queue. So queue.pop, and I'll pop it 0. I don't think it really matters, but I'll pop it 0. So now I've got a frequency that I know occurs more than once. Now what I can do here is I can remove one character, so basically reduce this frequency by 1, and put that back into our map here to see if I have duplicates of that frequency. If I don't, well, I should say if I do, then I'll add that frequency to the queue again for reprocessing. If I don't, then I can just move on. Okay, so for this one, I already know my frequency already is duplicated somewhere. So in this case, I can just add 1 to my result. Then I'll have a new frequency. And this new frequency will be the current frequency minus 1. Now I need to basically put that into my frequency to count map. Now I have a new frequency to count here. So put this back in my frequency to count map for this new frequency. Plus equals 1. So we've taken our current frequency, we've reduced it by 1 to a new frequency. We need to put that into our count map. We might have one that's already got that frequency, so this also might clash, and we might need to reduce that one as well. So let's check if we have this one already. So this it's the new frequency. So if this is greater than 1, we need to put this frequency back into the queue. So queue.append this new frequency. And then we just keep going until we run out of frequencies that have clashes. Okay, I think that looks good. Oh, one thing. What happens when we get to something that is non-reducible? Let's say we have a string that's just like A, B, C. Now A, B, and C, each one of those only occurs once. So I have to reduce A or B or C, or at least 2 of them. In that case, I might go to 0 of some character. So in this case, this new frequency, if it happens to be 0, then we don't need to add it to our queue. So let's just check here if we have a new frequency. So if new frequency, I'll actually do an explicit check, is not equal to 0, and we have more than one of that frequency in our count, then we have to append it to our list. Okay, I think this should do it. Let's run this and see how many errors I have. All right, looks like I have no attribute item. It's items plural. All right, try that one more time. Kabam, and it works. Let's see if we can pass all of the tests. All right, and just like that, we have a passing function. We're not doing great. We beat 41% for runtime and 93% for memory. Holy smokes, we crush it in memory. I'll take that as a win. All right, so we do okay, not great. We have a couple dictionaries here. We have a couple extra, like this new frequency we don't really need. So some of this could be reduced. In fact, we don't need these characters at all, this key. The fact that we're not using this key means that this dictionary could probably be reduced to some other type of data structure, something like an array maybe. So yeah, we could probably clean this up. I'm curious to see what other people are doing. Let's just jump to the top. Whoa, that is compact. Look at this. Oh yeah, see, they are using a set. Awesome. And they are using the counter. So they're using the collections counter. You can totally do that. It's a very Pythonic thing to do. So I just wanted to go through and do it using a dictionary, but yeah, you could totally use a counter. All right, they're using a set. They're calling these deletions. Mine's called result. They're going through every character and count. Oh, so this is nice too. So for every character and count in this, they're also using items. So in this counter, they're just going through every count and saying, if this count is in our set here, that means this frequency has a duplicate. So this frequency set you might call like unique frequencies. So if our current frequency is in this unique set of frequencies, that means it's a duplicate. Well, then we'll just keep reducing our frequency. In this case, they're calling it count. I would call that frequency and this like unique frequencies, but they'll essentially reduce their unique frequency or their frequency as long as it's in this set. As soon as it's not in the set, then it's a new unique frequency. They'll add that new unique frequency to the set so that when they go to the next frequency, it's in the set and we can see if it's a duplicate. Wow, this one's really nice. I like that. Okay, let's jump back. Maybe we'll try to speed this up, but that's not a big deal. Let's see, we could probably do frequency minus equals 1. That might save us a tiny bit. In this case, that'll be frequency. And this map, I guess I could turn this into a set, but then I'll have to keep track of, that does change how this works. I think I'll leave this as is. Let's see, this dictionary, do I want to keep this dictionary? Yeah, I think that's all I'm going to do. I don't want to do too much on this. We're already passing, and you know, it's a decent algorithm. It just isn't the fastest. A little bit of a gain there, not a lot. We could try popping -1. I don't think that'll make a difference. Holy smokes. That took us up to a 51%. Now we're just over half. Not too bad. Okay, well that's it for me. I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.